Have you ever looked up at the sky and seen this weird tube-like cloud formation? It's pretty strange, right? Well, today we're going to break down the science behind it using a simple little riddle. So what exactly is this beautiful but bizarre-looking cloud? Well, it's called a roll cloud, and today we're going to uncover all its secrets with the help of a challenge question. Let's dive in. All right, so here's our mission. I'm about to show you 4 statements about roll clouds. Your job, our job, is to figure out how many of them are actually true. Think you know your stuff? Let's find out. Okay, so we're going to break down each of these statements one by one. But first, let's start by clearing up some of the most common myths about these clouds. Let's bust some myths. First up, we're tackling 2 big misconceptions: their supposed connection to thunderstorms and the danger that people often associate with them. So let's look at that first statement. It claims that these clouds are attached to a thunderstorm. Well, that's just not true. In fact, a defining feature, the thing that makes a roll cloud, is that it's completely detached. It's a solitary, separate tube. The ones that are attached to storms, that's a different beast altogether, called a shelf cloud. So right off the bat, statement number 1 is incorrect. Now, for statement number 4, they are a direct precursor to tornadoes. This is another huge myth. See, roll clouds look like they're rolling horizontally, right? But they don't have that dangerous, severe vertical rotation that you need to form a tornado. That kind of scary rotation is a hallmark of funnel clouds. So that means statement 4 is also wrong. And just like that, 2 myths busted. Okay, so now that we've debunked the myths, let's get into the actual science. What really causes these incredible clouds to form? All right, let's talk about the correct statements. Statement number 2 says their formation is linked to atmospheric gravity waves, in Hindi, Vayumandaliya Gurutvakashar Tarange. And that is absolutely correct. The easiest way to think about these is like waves on water, but they're happening in the air. They form when a stable layer of air gets disturbed, creating these ripples in the atmosphere. So how does this whole process work? Let's look at it step by step. Step 1. Cool, dense air, maybe from a storm or a sea breeze, pushes underneath warmer, moist air. Step 2, this very collision is what triggers that atmospheric gravity wave we just talked about. And step 3, on the rising part of that wave, where the air cools and condenses, that's exactly where the roll cloud is born. Okay, on to statement number 3. And yes, this one is also correct. Another essential ingredient is something called a temperature inversion, or tapman vyutkraman. Now, normally, the higher you go, the colder the air gets. Simple. But in an inversion, it's the exact opposite. You get a layer in the atmosphere where the temperature actually increases with altitude instead of decreasing. Pretty weird, right? So what does this inversion layer do? Well, think of it like a lid or a cap in the atmosphere. It physically stops the rising moist air from going any higher. It just blocks it. And because the cloud can't grow upwards, it's forced to spread out horizontally, sideways. And that's what gives it that signature, long, tube-like shape. That's the biggest secret to how it forms. Okay, we've broken down all 4 statements. Now it's time to solve our riddle and get to the final answer. So let's recap. We've seen that statements 1 and 4 are both wrong. Roll clouds are not attached to thunderstorms, and they are not a sign of tornadoes. But statements 2 and 3 are absolutely correct. This means the right answer to our challenge, to our riddle, is only 2 statements are correct. So let's lock in these 4 key takeaways so you'll always remember what a roll cloud is. The next time you see one, just remember these 4 things. Number 1, it's always detached, totally separate from other clouds. Number 2, it's wave-generated, created by atmospheric gravity waves. Number 3, it's inversion-capped, thanks to that lid layer. And number 4, it's non-rotational, meaning no need to worry about tornadoes. Easy. So there you have it. You see how a seemingly simple cloud can have some pretty complex science hiding behind it. Now, the next time you look up at the sky, just think, what other amazing atmospheric wonders are out there, hiding in plain sight, just waiting for us to notice? Keep looking up.